The James Webb Space Telescope offers scientists an unprecedented vision of the universe, delivering remarkable findings that continue to excite the scientific world. And it has done so again. In a recent endeavor, researchers directed the Webb telescope towards the remarkable Whirlpool Galaxy M51, and they have discovered intricate details of the empty cavities and bright filaments in the propagating spiral arms of the galaxy. While it might not seem like a phenomenal discovery, this is the image that scientists have been waiting for.
You're watching Once Upon a Space.
This recently released hypnotic image allows us to gaze within a spiral galaxy floating some 27 million light-years away from our planet. The dark red regions trace the filamentary warm dust permeating the medium of the galaxy. The red regions show the reprocessed light from complex molecules forming on dust grains, while colors of orange and yellow reveal the regions of ionized gas by the recently formed star clusters. Utilizing two of its strongest instruments, the NIRCam, near-infrared camera, and MIRI, mid-infrared instrument, the James Webb Telescope has given us two perspectives of the celestial object. Both devices are built to capture the distant universe by decoding infrared light signals emanating from faraway stars and galaxies. With the distance of 27 million light-years away from Earth, the James Webb image is one of a series of observations intended to shed light on the interplay between stellar feedback and star formation in environments outside of our own galaxy, the Milky Way. First discovered in 1773 by French astronomer Charles Messier, the Whirlpool Galaxy, aka M51, is one of the most well-known objects in the night sky, and is the part of the Messier catalogue. M51 is known as the Whirlpool due to its whirling structure, which looks like water around a drain. It's 27 million light-years distant in the constellation Canes Venatici. Thus the image we're seeing is of the Whirlpool Galaxy 27 million years ago. But never have you seen an image like the one just captured by the James Webb Space Telescope, the most powerful of its kind. As such, this new Webb telescope video doesn't just represent a journey through space, but also a trip back through time. Stellar feedback has a dramatic effect on the medium of the galaxy and creates complex network of bright knots as well as cavernous black bubbles, said the European Space Agency, which helped build the telescope and launched it into space last year from its spaceport in French Guiana. Stellar feedback is the phrase used to describe the outpouring of energy from stars into the settings that generate them, and it is an important mechanism in influencing the rates at which stars originate. According to the agency, understanding stellar feedback is critical to developing accurate universal models of star formation. The Whirlpool has a younger sibling. The gravitational effect of M51's smaller partner is assumed to be partially responsible for the galaxy's distinctive, well-developed spiral arms. When Hubble captured an image of M51 more than a decade ago, the team behind it said that they couldn't wait to see the same image with the planned James Webb Telescope. This observation of M51 is part of a series titled Feedback in Emerging Extragalactic Star Clusters (FEAST) in short. The FEAST observations are intended to find and investigate star nurseries in galaxies other than the Milky Way. Other observatories offered glimpses of star formation prior to the functioning of the Webb telescope, either at the commencement or after the stars had destroyed their natal gas and dust clouds with their energy. For the first time, astronomers can see star clusters developing from their birth cloud in galaxies outside our local group using the Webb telescope. They can calculate how long it takes for these stars to contaminate the gas with newly produced metals and clear it out. By studying these processes, scientists hope to gain a better understanding of how the star formation cycle and metal enrichment are regulated within galaxies, as well as the timescales of birth and death of stars. And that's what James has done with its discovery of the Ring Nebula. With its state-of-the-art army of infrared sensors, the JWST managed to obtain images that provide unprecedented spatial resolution and spectral sensitivity regarding all that cosmic chaos, according to ESA's statement. What this means is the Spaceman telescope, which sits about 1 million miles, 1.6 million kilometers, from Earth, was able to reveal details about the Ring Nebula's intricate structure that scientists simply haven't passed before. When we first saw the images, we were stunned by the amount of detail in them. The bright ring that gives the nebula its name is composed of about 20,000 individual clumps of dense molecular hydrogen gas, each of them about as massive as the Earth. Within the ring, there is a narrow band of emission from polycyclic aromatic hydrocarbons, or PAHs, complex carbon-bearing molecules that we would not expect to form in the Ring Nebula. Outside the bright ring, we see curious spikes pointing directly away from the central star, which are prominent in the infrared but were only very faintly visible in Hubble Space Telescope images. We think these could be due to molecules that can form in the shadows of the densest parts of the ring, where they are shielded from the direct, intense radiation from the hot central star. For instance, by capturing infrared light wavelengths emitted by the nebula, otherwise known as light wavelengths invisible to the human eye, the JWST unveiled information about the inner ring's filament structure, as well as approximately 10 concentric arcs in outer regions of the phenomenon. Those target-shaped features actually came as a surprise. These arcs must have formed about every 280 years as the central star was shedding its outer layers. When a single star evolves into a planetary nebula, there is no process that we know of that has that kind of time period. Instead, these rings suggest that there must be a companion star in the system, orbiting about as far away from the central star as Pluto does from our Sun. As the dying star was throwing off its atmosphere, the companion star shaped the outflow and sculpted it. Roger Wesson from Cardiff University offered as an explanation, highlighting that no previous telescope had the sensitivity and the spatial resolution to uncover this subtle effect. It's also worth noting that this isn't the first time the JWST has pointed its hexagonal gold eyes toward the Ring Nebula. Very recently, the machine imaged this pocket of the universe in high resolution, and scientists added mesmerizing green and purple filters to create a pretty glorious scene for us to admire. The history of the Ring Nebula's observations signifies more than its physical components. It's a symbol of human curiosity and advancement. From the early misconceptions that led to its planetary nebula label to the advanced technology of JWST, our pursuit of understanding this phenomenon parallels the growth of astronomical science itself. The Ring Nebula was discovered in 1779 by astronomers Antoine Dauquier de Pellepoix and Charles Messier, and was added to the Messier catalogue, who found it when trying to follow the path of a comet through the constellation of Lyra. Today, the Ring Nebula stands as a symbol of astronomical archaeology. The colorful main ring, the remnants of a dying star on its path to becoming a white dwarf, is a vivid reminder of our cosmic connection. In studying the nebula, we are not merely observing a distant object. We are peering into the past, present, and future of the universe itself. Our own Sun may have a nebula when it finally expires in some 5 billion years, and it will become a white dwarf, though we'll almost certainly not be around to see it. It may seem bizarre that two different images of the same nebula can have such different colors. But Webb observes objects at infrared wavelengths, meaning our eyes literally cannot handle Webb raw images. The data-rich raw images just appear black before the Webb image processors translate the infrared data into visible light wavelengths, which is what they did with the image. bringing out certain aspects of the nebula in each image. From some of the deepest views of the universe to studying even the rings of planets in our own solar system, Webb is giving astronomers an entirely new view of space. What next discovery are you expecting from Webb? Let us know in the comments, and don't forget to subscribe to
Once upon a space.